Hello, my name is Thane Yazzie, and I am the STEM Education Outreach Coordinator for the Salish Research Center at Northwest Indian College. Today, I'm going to talk about resiliency in the face of COVID-19, which includes strategies for continuing Indigenous, STEM, and STEAM outreach and education through online distance learning. Northwest Indian College is a tribal college located in Bellingham, Washington. It has extension sites all over Washington state, including Idaho. It offers 2- and 4-year degree programs and is currently serving students through distance learning. The Salish Research Center is a grant-funded research lab that focuses on student and faculty-led research. This research includes harmful algae blooms, longfin smelt dynamics, and water quality, all within Bellingham Bay and the surrounding water. As STEM Education Outreach Coordinator, my job is to provide opportunities for students to learn about our research. Additionally, my goal is to teach students about broader science subjects such as ecology and biological diversity, which includes the food web and learning about how energy moves throughout various trophic levels. For example, phytoplankton being eaten by zooplankton, which are eaten by longfin smelt, and then continue up the food web. It is also important that we include harmful algae blooms and how they can impact various species, as well as ourselves. Because shellfish is an important food source for local communities, it is important to teach and share our research. For this next video, I'm going to share with you an outreach activity. Students here were able to fly a drone in which the drone represents a phytoplankton and the balloon represents energy from the sun. This activity is just one of many in which students learn abstract concepts in a hands-on and engaging way.
If you guys can help her out, what to do, that'd be great.
Go forward, go forward.
Yep, go forward.
No, the wrong way.
No. Good job, good job.
Stop.
That's all right.
Go down more.
You're almost there.
Go forward. Go forward.
You're almost there. All right, go ahead, go forward.
Oh.
Nice! Woo! All right, good job.
This next video shows students of Lummi Nation School doing a tour of a local salmon hatchery. After students learn about salmon, their habitat, and their life cycle, they engage in building aquariums in which they will raise salmon and then release them. Putting the aquarium together is another example of students learning abstract concepts such as healthy salmon habitat in a hands-on and engaging way. In this way, students are able to see why each component is important and how it relates to the natural environment. For example, a chiller is used to keep the water cold in a salmon aquarium. In the natural environment, salmon need cold water to survive. Other outreach activities include local species identification, in which students use identification cards to explore their own backyards, ocean acidification labs, where students use pH indicators to learn about acids and bases and how carbon dioxide impacts our water and our environment. Building an underwater rover, where students use PVC pipes and motors to build a water-capable vehicle. Acidic shellfish lab, where students weigh and measure shellfish before they are placed in vinegar or another acidic solution. Then after a week, students will weigh them and measure them again and see differences. Differences may include a loss of weight and deterioration of the shellfish cell. Building a water filter is another example of learning about abstract concepts and applying them in a hands-on way. Students learn about shellfish and how they filter feed, and then work on building a water filter using materials that they can find in their own backyard, such as gravel, sand, and charcoal. Another important component of our outreach is Indigenous concepts, such as interconnectedness and place-based design. This helps students relate and connect to their own culture, and as well as be inspired to make drawings of their own. Here is an example of student drawings demonstrating the sun and its energy moving throughout various species within an ecological food web. If you look closely, you can notice some students even drawing Indigenous style. Of course, all of these activities took place before COVID-19. When COVID-19 hit, we were unsure exactly how we would go about participating in community outreach. In the summer of 2020, we decided to launch a fully online long-distance internship. This internship would provide students with the ability to learn some of the things that I've worked on as a STEM outreach and education coordinator. Additionally, students would engage in their own project, which related to them personally, but also included a science or STEAM component. At the beginning of the internship, students were sent art and science kits. These kits included science experiments and supplies for projects they'd be working on throughout the summer. This project encouraged students to explore their own backyards. They identified 20 different species, including plants and animals. Students then researched the names and the habitats, as well as found interesting facts and placed all this information in documents that other students would be able to learn from. A build your own water filter. These materials were also found in their own backyards. Students had the opportunity to try different materials. For example, this student decided to include moss. Another activity, very similar to the outreach we've done in the past, was an ocean acidification lab. Included in the kits that we sent them was a pH indicator as well as an Erlenmeyer flask.
The pH is about 7 to 8. Blow air through the straw into the water.
We can visually see the change happen before our eyes.
So it turned yellow, so it went a little more acidic, right?
On this slide, we have examples of students' final projects. These projects were independently developed by students themselves. On the left, we see the story of the rain and people of the water, a story written about science concepts, but also including the story of a young salmon and a young boy. In the middle, we see environmental impacts of the Nooksack River. This project includes a narration written by our own intern alongside footage captured with our Salish Research Center drone. On the right-hand side, we have a comic book written by one of our interns, which includes information on indigenous plants and their medicinal values. Additionally, this intern decided to include her son as the main character of her story. Throughout the entirety of the internship, interns were encouraged to document their work in an art and science journal. In these science journals, interns would write a reflection about what they learned about throughout the day. Additionally, they were encouraged to draw and illustrate concepts or ideas. What these projects showed was how inspiring the younger generation can be. When given the chance, our students can teach us and even develop and create learning materials in ways we've never seen before. This next video is an example of an online learning activity that I've done with both students and adults, and I believe it is valuable for any stage of learning. Now, it is a drawing activity, so if you're watching this video, I encourage you to grab a pen or a pencil and a piece of paper and follow along. Also, the video is sped up for this presentation, so please feel free to pause along the way. Let's begin. We're going to start with drawing the nose. Start with the inside of the mouth, draw a curve, and draw along the back all the way to the tail. We're going to make the salmon look as though it is turning in the water. Now the bottom half of the mouth and the bottom half of the body. Next, we're going to draw the tail, also known as the caudal fin. Now, we're going to add the dorsal fin, which starts just behind the hump. We'll add the adipose fin, and then we're going to add the anal fin. Next is the pelvic fin, just below the bottom body. Now, we're going to add a gill and the pectoral fin, which is responsible for the salmon going up and down in the water. Now the eye, and now we will add some details to the mouth, including the teeth. And now we will add the lateral line. These are all the parts of the salmon we have drawn so far. Now, let's go ahead and draw the environment or the habitat for the salmon. We'll begin with some water and some crashing waves. This is important for salmon habitat as crashing waves provide oxygen. Next, we will add carbon or rocks and make sure the rocks are different sizes. Now we will add some eelgrass as eelgrass is protection for smaller salmon. Okay, let's add some more of the environment. Begin by adding some mountains, some islands, and some rivers. we'll add a sun, some clouds, which move precipitation and make it rain and snow in the mountains that provide water for the rivers. Adding trees provides shade to make the water cold, which is needed for salmon habitat. Now we will add some oxygen, and let's add some food, small fish, zooplankton, phytoplankton. We're going to now draw salmon eggs. A salmon egg nest is known as a redd. And once we have our salmon eggs at the bottom, we'll begin to draw the salmon life cycle. Let's begin with an alvin. As you can see, the small little patch yolk sac provides food for the alvin. As it grows, after 5 to 10 weeks, the salmon will become a fry. Again, we will make the salmon fry swim up into the eelgrass for protection. Eelgrass is protection for many species as well as a food source for many animals. After several months, the salmon will become what is known as a parr, and after 1 to 3 years, the salmon will grow into a smolt and move to the ocean. As an adult, the salmon will return to once again begin the salmon life cycle. This drawing represents many important elements of a healthy salmon habitat. The snow moving down from the mountain represents cold water. The trees provide shade to keep the water cold. Additionally, roots and rocks can filter sediment, keeping the water clear and clean for the salmon. 2 other important elements of a healthy salmon habitat are complex and connected water systems. Connected water allows salmon to travel back to spawn, and a complex ecosystem allows salmon to thrive with many different food sources. Here are some examples of student work. An activity such as this can be used for any level of learner. As an educator or facilitator using this activity, you may choose to include information that pertains to your particular lesson. Thank you for your time, and if you're watching this video, I hope you can take away some things that help you build online long-distance learning activities. And if I have one tidbit of advice, it is this. Our students are more inspiring, brighter, and smarter than they are even capable of knowing. So encourage them. Encourage them to be creative. Show them how to be leaders, and inspire them to change the world. Because who knows, someday they might just do it.